So electron configurations are basically arrangements of electrons, how they are arranged in the atom. You can think of it kind of like a seating chart where they're sitting, where you can find them. Electron configurations depend on what we call electron orbitals. There are many orbitals. They have different energies. And the electrons fill these orbitals in such a way that they occupy the lowest energy orbital first. So the first thing you need to know is we're going to do only ground state configurations in this lesson. So ground state means they are as close to the nucleus as they can be. There is things called excited state, or for example, when you do ions that look a little bit different, but we're doing ground state stable electron configurations. So one of the good things is when you do stable state electron configurations, the number of electrons you have to show is found out by the atomic number, because it's exactly equal. It's the whole idea when the protons and the electrons are the same because it's stable and neutral. So to tell how many electrons you have to sit, so for example with helium, all you're going to do is look on the periodic table, and you're going to find that helium's atomic number is 2, which is the same as just saying the number of electrons you're sitting is 2. So that's the good thing. The number of electrons you're going to write a configuration for is just equal to the atomic number, because it's stable, so the number of electrons equals the number of protons. You basically need to know 2 pieces of information to write electron configurations. The first piece of information you need to know is how to make what we call an Aufbau diagram. This tells you the order of the orbitals. So basically like the best seat in the house. It would be perfect if they went in right order, but they don't. They actually go in a little bit of a different order because of their different energy levels. So the way you draw the Aufbau diagram very simply is you start with 1s on the bottom, and you go straight up. 2s, 3s, 4s, 5s, 6s, and then 7s. Remember that the first energy level only has 1 sublevel. The second one has 2. So this s here, this 1, does not have a second level. So you're going to start here with the p's and go straight up. 2p, 3p, 4p, 5p, 6p, 7p. And then again, 1 has 1 sublevel, 2 has 2 only, 3 has 3. So we're going to do 3d, 4d, 5d, 6d, 7d. 1 has 1, 2 has 2, 3 has 3, 4 has 4, which we call an F. And there we go. There is such a thing as a G sublevel that shows up in the 5G. We aren't going to do electron configurations that you need to go that high, so don't really worry about that. So writing this diagram here is only the start. This isn't the whole diagram. So what I want you to notice is the first level 1 has 1 sublevels, 1s. The second level 2 has 2 sublevels. 3 has 3, 4 has 4, and so on. Now, in a perfect world, it would just go in that order. 1s, 2s, 2p, 3s, 3p, 3d, 4s, 4p, 4d. Of course, it's chemistry, so it doesn't do that. So what you're going to do is after you draw this, you're going to take the 1s, 2s. That's always the start, and that's something that's pretty easy to memorize, that it just goes 1s, and you're going to draw an arrow, and then 2s. Now the next arrows that you draw have to be parallel to the arrows, the first 2 arrows, and then you just keep going through the different orbitals. And what this does is if you follow the arrows, it gives you the fill order or the best seat in the house. So what it does is you always start with ground state, you always start with the bottom, the best seat, which is 1s. Once that is full, you start to follow the arrows, like follow the yellow brick road. So after 1s, the next best seat is 2s. After that's full, the next one is 2p. Then 3s, 3p. Now, it's not 4d, you follow the arrow. The next best level is 4s, 3d, 4p, 5p, and so on. It is not necessary to memorize this if you can draw this diagram. That gives you the fill order. The only other piece of information you have to know is the maximum number of electrons that can fit in each of the type of sublevels. So in an S sublevel, the max is 2. In a P, the max is 6. D is 10. F is 14. Remember that only 2 electrons can fit per suborbital. S has 1 suborbital, 1 bedroom if you're thinking that example, and that's the max. If you know those 2 pieces of information, you can write any electron configuration. So what we're going to do here is we're going to start easy with helium. You're going to start by telling the location. The location is right here, the 1 in the S. So you always start there. You always start with the 1s orbital. So I'm going to write 1s. That is just a location. It's like an apartment building. The first floor, the first apartment. So a lot of apartments are labeled like that. 1A, 1B, 2A, 2B. So it's the same idea. 1 is the floor, S is the apartment. This is just a location. And then what you're going to do is fill that with electrons until all the electrons have been seated. So in this case, I only have 2 electrons to sit. The max of an s orbital is 2. So to indicate that there's 2 electrons in that location, you put a 2 like a little superscript like that. So when you see this electron configuration, it's really important. It's so important, I think I'm going to get the lightsaber out. 1s is the location. This 1 has absolutely nothing to do with how many electrons are there. It's just a location. This is telling you first floor, S apartment or S seat. The 2 here is what tells you how many electrons are there. This is saying there's 2 electrons in this location. So the nice thing here is that everything is just going to go in that order. The nice thing is it's a very nice pattern. So Na, we're going to do Na now. Again, the number of electrons you fill depends on its atomic number. It's just equal to that because the protons and electrons are the same. So you're going to fill 11 now. You always start the same. You always start with 1s, just like you did before. Now the issue though here is you have 11 electrons to sit, but S's can only hold a max of 2 electrons right there. So what you got to do is you got to indicate, okay, there's 2 here. You still have 9 more to go. So what do? You go to the next orbital. So 1s is full. The next one is 2s. So I'm going to write 2s. It's like first floor, second floor. It is still an S. Every S, no matter what number comes before it, can only hold a max of 2 electrons. So after this, I have 4 electrons seated. 2 plus 2 is 4. I still need to keep going because I need 7 more. So after the 2s comes the 2p. Another location, remember. Now the p orbitals you see over here can hold a maximum of 6. So I'm going to put a 6 in the superscript now. So now if I go back real quick and count, I have 6, 7, 8, 9, 10 electrons are seated. I need 1 more. The next orbital after the 2p is the 3s. Now in this case, the s can hold a maximum of 2, but there's only 1 more electron that needs to be sit, so you put a 1. You do not put a 2 there. You're saying there's 1 there. And then what's going to happen is if you add together the superscripts, it's going to equal the number of electrons you had to sit. So 1, 2, 3, 4, 10, 11, 11 electrons. You do not multiply them. Remember, this 2s is a location. You don't do 2 times 2. The 2s is the location, first floor, second floor, third floor. The 2 is how many is there. 2 in here, 2 electrons in here, 6 in here. So next we're going to look at magnesium. Magnesium, if you look on the periodic table, has an atomic number of 12. So we're going to sit 12 electrons. Again, it's a pattern. You always start the same way. You're always going to start at the 1s, and you're going to fill until 12 electrons are seated. So the 1s, S has a maximum of 2. Obviously, that's full. The next best electron following your chart is 2s. That's also full with 2. Next best orbital is 2p. That has a maximum of 6. We only have 4 seated, so it is 6 that's full. Now if you count, we have 6, 7, 8, 9, 10. The 3s orbital then has 2. So if you're still a little confused about where this is coming from, you follow the arrows. 1s is your first orbital, then 2s, 2p, 3s, 3p, etc. and so on. And this is your max number of electrons. Once you hit that max, doesn't matter if it's a 1s orbital, a 2s, it's still a max of 2. Doesn't matter if it's 2p, 3p, it still has a maximum of 6. Then you move on to the next one. So next we're going to do boron. Boron has an atomic number of 5. So again, you're always starting at the 1s, 2 in there. Next orbital is the 2s, 2 in there. And then we're going to do the 2p with 1. So now we're going to look at chlorine. Chlorine, we're going to sit 17 electrons, so a little bit more here. But again, no matter what, you're always starting with the 1s orbital, max of 2. You're going to use your aqua diagram. See, the next best orbital is 2s, max of 2 in there. Next would be 2p, max of 6 in there. I'm kind of going a little bit quicker because I know I'm going to have to sit 17. Next orbital is 3s, max of 2. So every so often you probably should just stop and count just so you have, a little bit of an idea of where you are. So right now, if you count, I have 1, 2, 3, 4, 10, 12 seated. I still need 5 more. My next orbital is the 3p. P can hold a maximum of 6, but since I only need to sit 5 more, you would put the 5. Remember, you don't put the max, you put what it actually would be. So now we're going to do strontium. Strontium has an atomic number of 38, so that means we're going to sit 38 electrons. So that's more than we've done, but the good news is you're just going to follow the same pattern. You're always going to start where you have been starting, which is 1s. Now when you have a lot to fill, like 38, you can kind of just keep going and not really count all the time. I usually say, maybe stop at the first 3D. So let's see how that works. So first you're going to do 1s maxed out with 2. 2s maxed out with 2. 2p with 6. 3s with 2. 3p with 6. So that's what we've been doing. But now if you follow the arrows, after the 3p does not come the 3d. It doesn't go this way. You follow the arrow up to the 4s. That's where it starts to get different. Follow the arrow up to the 4s. So now you're going to do 4s2. And then 3d10. Here I would kind of stop and do a count just to make sure you're on the right track. So we have 2, 4, 10, 12, 18, 20, 30. So we've sat 30. We only need to seat 8 more. So that's where you can kind of pay attention. So after the 3D comes 4p. Maximum of 6 would give us 36. And then after that comes the 5s with a max of 2. So again, if you're not sure, watch what we did. So follow along down here as I show you. 1s, 2s, 2p, 3s, 3p, 4s, 3d, 4p, 5s. So after about the 3p, they don't go in the straight order. You have to use the aqua diagram to figure out the order. So now comes zinc. Zinc, you're going to sit 30. So again, start with the 1s. You're going to do 30, so you can kind of cruise along, filling as you go. So 1s, 2s, 2p6, 3s2, 3p6. Remember, after the 3p comes 4s. I would stop for a second, do your counts. 2, 4, 10, 12, 18, 20. I only need 30. So the next orbital is the 3D. The 3D can actually hold 10. So to go from 20 or 30, you fill that with 10. And finally, we're going to do Y. Y, you need to sit 39. you know you're going to go a while, so once you get good, you can start with the 1s2 and just kind of cruise along, filling them to their max. So 2p6, 3s2, 3p6, 4s2. Eventually you're going to do so many of these, you're going to realize once you get to the 3d10, that's 30. So you're only going to need 9 more, which is 4p6 is going to give you 36. 5s2 is going to give you 38. And then you got to go to the next one, which is going to be 4d, but 4d is only going to have 1 in it. What I want you to take a look at real quick is the similarities. If you look at this in terms of where they're similar, there's a lot of similarities. They're kind of all the same, especially if you start to look here. They're all very much the same up into a certain point. If we go up and we look here, 1s2 to 2p6 are the same. So what's going to happen is this is going to come back when we do orbital diagrams or noble gas notation. I just want you to notice there's a pattern. Once you get the pattern, once you know the Aufbau diagram and you know the max number of electrons, it's very simple. It just becomes a pattern. So go ahead and practice some on your own.